Hello. Now we are going to look at how we can solve probability questions more easily using Venn diagrams. So we know that translating the language of probability, figuring out what the question is really asking us and what information we have, is often the most challenging part of a probability question. The maths tends to just be simplifying fractions. So in aid of telling the story of the questions we're given, it is sometimes helpful to use Venn diagrams, and sometimes in the exams we will directly be given Venn diagrams and asked probability questions, but they're also a more general tool for understanding questions. So let's look into it. In a class of 25 students, 15 study Spanish, 10 study German, and 3 study neither. Our first job is to fill in our Venn diagram. Well, I have sketched out our Venn diagram here. Our universe in this question is going to be the class of 25. So in my square brackets, I put in 25. S is going to stand for studying Spanish. And there are 15 people in total who study Spanish. There are 10 people in total who study German. And there are 3 people who study neither. Now this 3 here doesn't have a dot next to it because it's a cardinal number of a set. It's the number of people, the number of students that don't study either Spanish or German, but they are in this class of 25 people. If this was the element 3 as part of a set, then we put a dot next to it. The absence of a dot tells us that we are dealing with a number of people or a number of elements rather than the element 3. Now, moving on. I have now filled in all of the information that I have got for this question, but I can immediately see a problem. I don't know exactly how many people only study Spanish, how many people study both, or how many people only study German. But do I have enough information to figure it out? Well, I always try and fill in the center of the Venn diagram first. So I'm going to say, I don't know this, so it's going to be X. X is my unknown. How would I describe the 15 people who study Spanish, the 15 people in total who are inside this circle in terms of X? Well, there would be a total of 15 people minus the X that are studying both in this part of the Spanish circle. And in the German circle, there would be 10 people in the total German circle, and X of them are already accounted for in the intersection in the people who study both German and Spanish. Now, if I add up the number of people in this set, the number of people in this set, the number of people in this set, and the number of people in this set, I have to get the total number of people in the class because all of the elements of my universe, all of the subsets, I should say, of my universe have been accounted for. And if I add them all up, I have to get the number of elements in the universe. So 15 minus X plus 10 minus X plus 3 must all add up to 25 students, the 25 students that make up the class. So we add up our like terms. And I have 15, and I have 10, I have 3. So I add up all of my like terms. And I get 28. 28 minus X is equal to 25. Now I need to rearrange this equation in order to find out what X is. So I need to subtract 28 from both sides. So I have X on the left-hand side and numbers on the right. So minus X is minus 3. Dividing by minus 1 or multiplying by minus 1 would work in this case as well. X must be equal to 3. So that means X is equal to 3. And I can fill in the rest of the parts of my Venn diagram. So 15 minus 3 is going to give me 12. People only study Spanish. 10 minus 3, so 7 people only study German. And as I have a little bit of a messy stuff going on here, I might underline those so I don't get confused as to which number I'm talking about. Now, what's the probability? Now that I have all of the elements, or all of the subsets, I should say, of my Venn diagram filled in, now let's get into our probability element. This was essentially a recap of our knowledge of sets and how we can solve stuff in Venn diagrams. What's the probability that a student studies Spanish? Well, for that, any probability question, I want probability of S for Spanish. That's going to be wanted over total. How many outcomes do I want out of the total? So that's going to be 15 students would meet my criteria, would be the students I'd want to get out of a total of 25. So I have a highest common factor of 5, top and bottom. So we show how we are simplifying. And we get 3 out of 5. And we always simplify our fractions to get full marks. Now, what is the probability that a student selected at random studies German only? So we look to how many people meet that criteria. So we want to describe this in set notation just for some practice. So what's the probability that they study German only? Well, that mean they study German, and in this case it would mean they do not study Spanish. So German, but they don't study Spanish. So there's only 7 people who meet that criteria. So that would be 7 out of 25. And as that doesn't simplify, that's our job done. So anytime we can, we want to try and bring in the language of sets so that we are reinforcing what we know in different areas of the course. Because in the exams, they can bring those different ideas together. So if we're using the language of probability along with the language of sets, we're doing a lot of work all at once. What's the probability that a student selected at random studies neither of the subjects? Well, what students meet that criteria? So studies neither. There's a few different ways we could describe that, but S union G complement would be one way to do it. So we want all of the people, S union G complement would be a way to describe that. That's a comma. Or an apostrophe, I should say, not a comma. Would be all of the people who don't study Spanish or German, and 3 people meet that criteria. So that would be 3 out of 25. Again, that doesn't simplify, so that's our job done. What's the probability that a student selected at random studies both of our Spanish and German? Well, there's only 3 people who meet that criteria. Now, how would we describe the people who study both? That would be Spanish intersection German, the people who study both Spanish and German. So that would be, again, 3 out of 25. And just putting it in sets language, that would be the number of people who study Spanish intersection German over the number of people in our universe. So that would be a sets way of describing that. What's the probability that a student selected at random studies Spanish or German or both? How would we describe that in sets language? We'd be talking about the union of Spanish and German. So if we're in either of the circles or both, we'd be happy. And that is going to be 12 plus 3 plus 7 people. Out of a total of 25. And that gives us 22 people out of 25. And that is our job done. And studies, what's the probability that a student selected at random studies one language only? Now this would be a little bit complicated to describe it in sets language, but we can do it. So that would be probability. We want this group here, and we want this group here. And there's a few ways that we can describe that, and I'll give you one of them. So that would be S union G. So that would be everyone in the circles. And then how would we exclude the people who are in the intersection? We could say not the intersection. Now, there is more than one way to describe that, and it's perfectly fine whichever way you want to do, but playing this game of using the sets language is helpful for understanding sets language at a deep enough level that if they ask us something unusual in the exam, we can handle it. So that is going to be 12 plus 7 people meet that criteria out of a total of 25, and that gives us 19 out of 25. Now, if we get a question involving 3 sets, we do exactly the same thing. Nothing changes. We're just going to do another example so we can see it in action. In a town, kids play hurling, Gaelic, or soccer. I should say play. So kids play hurling, Gaelic, or soccer in this town. So we're now reading to the side of the Venn diagram. If 15 play Gaelic and soccer, how many play all three? So 15 play Gaelic and soccer. So we tell ourselves that story. Gaelic and soccer would be the intersection of these two sets. So that would be this group here. So what we are going to do then is say, well, we know there's 15 people overall in this group. Well, there's 6 in this part of the group. So how many play all three? Well, we'll call this y because we already used x. Y plus 6 must add up to 15. So by looking at the Venn diagram, we can tell ourselves that story. So y plus 6 must be equal to 15. Rearranging our equation, y must be equal to 9. And again, fill that in on the Venn diagram. If we get a new piece of information, fill it in. And now we can fill in all of our different parts of our Venn diagram. So how many people will play hurling in total? We'd add up all of our different pieces, 12 plus 4 plus 4 plus 9. And we get 29. And for Gaelic, we get a total of 24. And for soccer, we get a total of 21, just by adding up the elements in the complete circle. So 4 plus 9 plus 6 plus 2, we add up to 21. Now, to find the total number of people in the universe, we'll just write it out here. You can just add it up as we did before for the hurling, the Gaelic, and the soccer. But just for completeness, that would be 12 plus 4 plus 4 plus 9, and so on, adding everything up, and that's going to give us the total number of young people in the town. And we get that there's a total of 50 kids, 50 young people in the town. Now, what's the probability if a kid plays soccer? So we go to a soccer and we say, well, it's a probability that a young person plays soccer. That's going to be the number of people who play soccer out of the total number of people, young people, in the town. And we now know both of those figures from filling in our Venn diagram. Sorry, I should write that up in my Venn diagram. I have 50 people in total in my square bracket telling me the cardinality of an overall set. And I add that up, or have added that up, and I get 21 out of 50. I don't think I can simplify that. So then I look at the probability that a kid selected at random plays soccer only. Well, I look at the people who meet that criteria, play soccer only. So that would be soccer, but not hurling or Gaelic. Bracket. So how many people meet that criteria? That would be only 2 out of 50. I have a common factor of 2 top and bottom. So I divide out my common factor and always show that we're doing that. And we get 1 out of 25. None of the 3. So there are some people in the town who don't play any of those games. That's going to be the probability of selecting someone who doesn't do any of the 3. And that's going to be the universe, not the union of all 3 sets. That's 8 out of 50. That's the people out here. And that simplifies to 4 out of 25. And hurling, but not Gaelic. So hurling, but not Gaelic. Well, we have to be careful here. That's in the hurling circle, but not in the Gaelic circle. So both these 12 people and these 4 people. We don't mind whether they play soccer or not. So long as they play hurling, but don't play Gaelic, and that's going to be 16 out of 50 is 8 out of 25. And that's what we need for now.